7-2 day 1, pre-lesson. So we've been working a lot with graphing, a lot, and there's your x-axis, there's your y-axis, but this is considered quadrant 1, 2, 3, 4. You probably knew that, but I just want to make sure you definitely did. So we're going to enter into a different world of trigonometry, and there's a whole bunch of little phrases that you just have to kind of understand before you understand the instructions for your homework. It's not hard, but the instructions can make it seem hard, so let's get through all the vocab. So in this line of trigonometry, you're going to have that thing. Now, I try to dummy things down so that you can kind of go, oh, I get it. So this is, think of a game of Twister. If you've ever played Twister, you take the little board with a spinner on it, and you spin it. So I call this my spinner. Now, that's not what math is going to call it, but you, when you're doing these problems, you always start here. That is rule number 1. Now, if you're playing Twister, unless you're really OCD, you're not going to start the spinner in the same spot every time. You're just going to, wherever it ended up last, you just hit it and it spins. But in trig, you got to remember to start here every time. Now, this side has some names. First of all, that spinner right there is considered in standard position. So when you see instructions talk about standard position, don't be confused. They're just reminding you, you got to start there, but it might throw you off a little bit. Don't let it. This is also called the initial side. That means it's where you started. Now, I want you to really think about this. Why did they call it a side? It doesn't look like a side. It is a clue. It's a clue, okay? But I'm going to make sense of that coming up in a minute. So here's the thing. If I take my finger and I hit this thing that's in standard position, the initial side, and I hit it up, whoopsie, up is equal to a positive spin. We're going to talk more about that. So let's say I hit it, and it goes all the way to here. All right. And I'm just going to say it stops right there. Okay? A couple of things. Number 1, this is now called the terminal side. Okay? If you have a terminal disease, I know this sounds terrible, not what you want to think about, but it means, it's something you're not going to survive. It's where everything ends. I'm sorry if that was too deep, but that helps you remember that's where the side stops. Okay? So terminal side, boom. Now, if we have this angle here, that's our angle measure. We're going to call it theta. Now, I could have called it alpha or anything, but the book starts by naming that angle theta. And now we're going to have to talk about some other things. Let me get my thoughts together here. All right, glad I stopped to check. I almost erased this, but from this drawing, I'm going to explain this word, side. Remember I said, hey, that's a clue. What are we doing? Well, we're actually building triangles with our spinner. Okay, how? Well, when our spinner comes to an end, it has the tip of the spinner right here. We've been dealing with SOHCAHTOA, right triangles, so we have to build a right triangle. Here comes an always. Always. To create your right triangle, always extend a line from end of spinner to, here comes the x-axis. Never, ever to the y-axis. All right. So I'm going to make a mistake to get started, and I'm going to erase it. It's in green. Students will go, oh, okay, there. I've got my 90-degree triangle. you just broke the rules of trigonometry. That's a big no-no. Students will do it though. You have to go to the x-axis, which means down. The reason that's so important is because there's another rule that's like massively important. See this angle right here? I'm going to call that alpha. We know this is a 90. This angle right here, we're going to call alpha, and that is called the reference angle. So in this case, the alpha is called the reference angle. Now, there's some things I'd like to say about it. I'd like to get a marker that works. The reference angle, remember, in SOHCAHTOA, it's all about what's the reference angle. Am I supposed to look at theta? Am I supposed to look at beta? Am I supposed to look at the 30? Am I supposed to look at the 27? I'm helping you understand this is what you are to concentrate on. So that would make this my opposite side. This is my hypotenuse. By the way, the spinner is always the hypotenuse. And that would make this my adjacent side. So you've got trigonometry. Every time you spin a spinner, it's got an infinite number of possibilities as that spinner goes around the four quadrants. With that being said, here's a rule. The reference angle is always, I can't emphasize this enough, sandwiched, sorry if you're hungry, between the x-axis and the spinner. Now, I could have written hypotenuse down for spinner, but I just hope you just know that. The spinner will always be the hypotenuse. If that doesn't make sense, it will. So let's follow this definition. The reference angle, now remember, I could put like beta in there, but the book is going to start with alpha. It's sandwiched between the x-axis, here's the x-axis, and the spinner. Here's the spinner. There it is. It's right in there. Here's a piece of bread, here's a piece of bread, there's the meat, whatever. However you want to think of it. It's not this one, and it's never the 90. Keep that in mind. So, here's a question that's built on that pre-lesson. So it says, spin your spinner 120 in standard position. You should know already. It's like, okay, all that means is start your spinner there. Don't worry about the length of the spinner right now. That's insignificant. Spin it 120 degrees. Well, because it's positive, it means up. So I go like this. There's 90. And I would recommend that you be accurate with this. Don't just haphazardly put the spinner somewhere. I need to go 30 degrees more, which is about it is 1/3 of 90, so it would be right about there. And your drawing is going to matter. Find the reference angle. Remember, we're going to call it alpha. Well, that would be right here. Now, you might pat yourself on the back and go, yay, I found it, kind of, but they actually want you to calculate it. This is where your supplementary angles are going to come into play. X and Y. You know, what's x plus y? Well, that has to equal 180. It's a little geometry here. Well, this is 90 plus 30, so the whole thing is 120. So if I subtracted 120 from 180, wouldn't that give me 60 degrees? And then there, you did it. You found it. Now, the book may also ask you questions like this. They might say, all right, if your reference angle is 60 degrees, if your reference angle is 60 degrees, so, and you're in the second quadrant, how far do you have to spin your spinner? Or what is your angle? So that would be asking you to find that, which is 120 degrees. So it's the same question. It just depends on what they give you and what they ask you. All right, let's pause that a minute. Now, I haven't said this yet, but negative means go the opposite direction. You go this way. So, got to start in standard position. That's my initial side. Don't be thrown by all that weird language. This means I got to spin the spinner down. So I take my big thumb and hit it down. Well, I got to take a piece out of that. That's down 90. And then I have to keep going 30. And then my spinner stops right there. There's the terminal side. And now it's asking you, what is alpha? Do not forget the definition. It's always sandwiched between the spinner, here's the spinner, and the x-axis. Guess what? It's right there. Now what if you have to say exactly what it is? Well, it's the same problem. 120. See these negatives? If I took out a protractor and I measured it, that would still be 120. You don't have negative degrees, you just have degrees going down. So essentially, that just tells me direction. So 90 plus 30 is 120. So the reference angle is still 60. And so now what if they ask the question in reverse? What if they asked you, okay, you have a 60-degree angle, a 60-degree reference angle in the third quadrant. How far did you have to spin your spinner? Well, one student might say, aha, that'd be negative 120. Without them specifically saying, find a negative angle, somebody else might have said, I spin it that far, which is 180 from here to here, plus 60, which is 240. So what I'm saying is 240 is equal to negative 120. So these are called coterminal angles. It means they're different spins, but they end up in the same exact spot. More on that coming soon. All right, here's the word coterminal. Find one positive and one negative coterminal angles, angle of 210. So we have to know how to get this stuff started. We always start here. Because there's an invisible positive, it means up. So I know I have to go 180, and then how much farther? 30 degrees. So it's like right there, and I'm going to stop right there. Now, if they ask me what the reference angle is, I could say it's 30, but that's not what they're saying. They're saying find one coterminal positive and one negative. So that means if I go back to the standard position and I spin it this way again, what's a different number other than 210 that would end up in that spot? Well, if you notice, I went 210. I can't put the actual problem down. It is correct, but they want a different positive degree measure. So all you're going to have to do is go around a full revolution again. So essentially it's 210 plus another revolution, so that'd be 570 degrees. So you go there, and then you got to go around again. So it's the original plus 360. Now I'm going to get out a green marker. How do you find the negative one? Well, that would be starting here, and I have to go down there. Well, if this is 210 this way, that's 180 plus 30. That helps me understand that I'm going a negative direction. Here's a chunk of 90. Here's a chunk of 60. 90 plus 60 is 150, so I'd write negative 150. So that is coterminal with this, and all three of these are considered coterminal angles. I got 1 minute to cram this last problem in. So they're going to tell you, spin your spinner 120. They're going to ask you for a couple things. First of all, what's the reference angle? Well, you should be able to just say, you know what, it's 60. And then they're going to ask you for this point, xy. Well, you want to build a triangle. Remember, don't ever go to the y, always go to the x. And you're like, wait a minute, I got a 30, 60, 90. Here's a confusing thing. They don't give us dimensions. It's a 30, 60, 90, so we're going to just use whatever makes sense to us. So I like to make this side a 1, but remember, that's this way, so it's negative 1. But if that's a negative 1, hypotenuse is 2. This is the square root of 3. Now hold on a second. I'll talk more about why that -1 is a -1 and why the hypotenuse is positive.